So today we're going to multiply polynomials, and wait for more people to get here. Maybe we'll have some more costumes. That'll be good. Anyway, let's see. Here we go. What do we want to start with? I want to start with recall, by the way, before we talk about multiplying polynomials in more detail. I want you guys to recall some exponentials. And exponentials, for example, we can have x to the second power. And what does that mean if we have x to the second power? Do you guys remember? What was an exponential? Right? An exponential was really repeat addition. So if they ever ask you, sorry, not repeat addition, repeat what? Multiplication. If it ever comes up at some cocktail party that you're at one day and they want to know, hey, what's an exponential? You can always say simply that it's repeat multiplication. For example, x to the second power really is an exponential. The question becomes, what do you repeat? You repeat the base, okay? Now, this here, this letter x here, this is what we call the base, or we label the base. The base is what we are repeating. This number here, known as the power, informally, or the exponent, okay, is how many times you repeat the base. So if the power or the exponent here is 2, you repeat this base how many times? 2 times. Is that right? And an exponential is repeat of that base twice and multiply. So just so you guys know, x times x, or let's review, is really x squared. What would you say x to the third power is? Yeah. What's the base again? X. So what are you going to do with this? We're going to repeat that. How many times? 3. And multiply. Okay, you guys okay with that? There's nothing special about the letter x. They could give you a letter y, maybe y to the 4th. How many y's do you have again? 4. So we got y times y times y times y. So you guys know that exponentials are simply repeat what? Multiplication. You repeat this thing called the base. This is called your power. Okay? So let me give you guys a fact or a definition of an exponential. And we won't get very heavily into exponentials today, but it'll come back. We'll talk more about it. You have, let's say, they give you a b to the n. They'll use b for the word base. And what that is I have all of these b's multiplied together. And then you say, well, how many b's do you have multiplied together? Well, we have, what's the power? We have n of these. Okay? So we have n of these. Okay, and your exponent, or power, b, again, your what? Your base. So we're going to use kind of some of these ideas today in multiplying polynomials. Okay? So you guys okay with that? Right? Anybody remember this kind of stuff before? You ever see this before? Okay, well, let's see. For example, we're going to start with some simple multiplication, right? If I say you have 3x times what? X, what would you say here? What is this 3x times x here, since we're multiplying? Is it 4x? Be careful. This is what? Multiplication. So let's talk about this, right? 3x times an x is really, well, what's happening with the 3 and the x anyway? Isn't this also multiplication? So this is really 3 times x times another x. Okay, you okay with this? And so this becomes 3 times, what should we call that? X to the what? Second power. This is our shorthand because we see repeat multiplication of this base. You guys okay with that? Is that easy or is that hard? Is that pretty easy? Okay, so the idea is that you recognize that you have an exponential. Let's give you another example. Let's see if you're awake. What if you had 3x times 2x? Here's a multiplication. Another multiplication problem. What's 3x times 2x? Well, what's happening with the 3 and the x? Multiplication, okay? What's happening with the 2 and the x? Multiplication, okay? And we still have our multiplication sign here. So the question I'm going to say to you now is, how do we simplify this, or how do we multiply this? Okay? How are we going to multiply it when it's written this way? Anybody know? How do you multiply this? Well, here's what I want to remind you. Here's what you guys want to know or say. That the order in which you multiply what? Does not matter. Meaning, if I have a string of multiplication any time in my life, times, 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 multiplication, I can switch the what? The position and the order in any way I like. So I want to switch it in a way that helps me write this in a more simpler way. Meaning, I'm going to switch these two, my x and my 2. Okay? Meaning I'm going to change their positions or put 2 first and then x second. Because the order in which I multiply what? Does not matter. And I'm going to write that down. The order of multiplication does not what? It does not matter. So the order in which you multiply will not matter. I'm going to switch the order of x and 2. So what I end up with here now is going to be 3 times 2 times what? X times x. What do you guys notice about this? What's the benefit of doing that? Anybody see a benefit here? What's 3 times 2? 6. And then times, what's x times x? Is that x squared? So you end up with what? 6 times x squared is going to be 6x squared. Okay, you guys okay with this? Right? So you're noticing that you have repeat multiplication here of a base. How many of that bases do you have? 2. Let's give you another example. What if they gave you negative 4x squared times, let's say, 3? What are you guys going to do with this? Right? How are we going to multiply here this negative 4x squared by a 3? Anybody know? What do you think we're going to do?
Multiply negative 4 times 3.
But what's your justification? How can you do that? All right. Well, what's happening with this here? Isn't there multiplication as well? So the justification is that the order in which you what? Multiply does not what? Matter. Is that right? You guys okay with that? I should have brought my costume. You know what I was last year? Should I tell you guys? What was I last year? Captain America. What was I the year before? The Captain America. Oh. What was I the year before Captain America?
What were you this year?
What was I this year? You ever watch the movie Gladiator? That's what I'm going to be. this year. No, actually, I was that the year prior. This year, I don't know. I think I just put my Batman t-shirt on. Don't know. Anyway, what's negative 4 times 3? It's negative 12. That's negative 12 times x squared, or simply what? Negative 12x squared, okay? This is not too hard to do. I just want to justify what I'm doing. I'm going to say that the order in which you multiply does not what? Matter. So I'm simply switching the order of multiplication. I can do that for what operation again? Multiplication. Okay? So there we go. So let's work on some more of these examples, because these are the basis or the foundation for multiplying with polynomials. So let's take a look at some of these examples. And another example is going to be if we have maybe negative 4x squared times a what? A 3x. What happens now? What do you guys think? How is this problem different than any of the others we work with? The answer is it's not. They're all multiplication, by the way. And I want to point out again, what's happening between that negative 4 and the x squared is also what? Multiplication. So let me write this all out for you. So what's happening here, by the way, is multiplication. Here, multiplication. Here also, 3 with x is really 3 times x. They're all multiplication. And again, I'm going to say, you're going to switch your what? Switch the order of your multiplication. Because when you have a string of multiplication, the order does not matter. So I'm going to switch the order in such a way that I help myself. So negative 4 times what? 3 times x squared times another what? X. Do you guys agree that I just switched the order of what I had here? Is that true? And I switched it in a way that I can multiply the constants of a negative 4 and 3, which gives me negative 12 times, again, what's x squared times x? What do you guys think is happening here? X squared times x. Well, what was x squared anyway? Isn't this x times x? Isn't that for my x squared? And then I'm going to have another one out here, another x. You guys with me on this? So what do you have then? How many of those bases are we repeating? 3, so it's negative 12, x 1, 2, what? To the third power. We're cubing it. Okay, you guys okay with that one? So I want to point out to you, I'm going to keep this, let's color coordinate this again. This is still an x. I'm going to point out to you that what you have over here came from the repeat multiplication, exponential, x times x. But we now have another one, so that makes it 3. Okay, you guys okay with that? Anybody have any questions on this one? We're not multiplying polynomials yet, but we're almost. And what if they gave you, for example, let's see if you're really awake, negative 4x squared times a, and I'll put a parentheses, negative 3x squared. What do you think's happening now? Anybody know? What do we have? We have some multiplication here. Okay, now what's happening here with the negative 4 and the x squared? Isn't that also multiplication? So you get negative 4, you got x squared. What's happening between the negative 3 and the x squared? Anybody know? What's going on here? Don't you also have what? Multiplication here and here? But this is multiplication, and I'm putting my parentheses. Do you guys remember, why do we put our parentheses, by the way? What are we trying to emphasize? That we have this negative number here. Okay? So what I'm going to say to you is what you can simply do is notice we don't need to emphasize x squared is negative. So in some ways, we could just put this parentheses around what we're trying to emphasize, which is negative. Now are you able to switch the order in a way that helps yourself? What do you think? Can you write this as negative 4 times negative 3 times my first x squared? Don't forget to multiply it by the second x squared. In other words, once again, we have that string of multiplication. We can switch our order because order doesn't matter when you multiply, right? Is 5 times 3 the same as 3 times 5? Is 4 times 8 the same as 8 times 4? So the order in which you multiply doesn't matter. So then now, what's negative 4 times negative 3? 12. Okay. What's x squared times x squared? Anybody know? Uh-oh. What do you think x squared times x squared would be? What is it? Well, if we don't know, how do you write x squared? Isn't that x times x for the first x squared? Times, what about the second x squared? Isn't that x times x for the second one? Right? And so what do you guys notice? Do I have repeat multiplication of the base x? Yes. How many times do I have it? 4. So that's 12x to the what? To the 4th power. All right. You guys like that? Anybody have any questions on these so far? Nope. You guys are good with this? You sure? How about if we give you let's test you a few seconds on some of these. We're going to try this out. See what you can do. For example, let's give you some examples now. You can do this on your own. Okay, how about this? 6x times 3. 6x times 3x. Let's change the letter. Negative 4y times 5y cubed. Negative 2y times negative 3. Two y squared times negative 3. Two y cubed. All right, let's get away from the number 2. How about if we say 4y cubed times 3y squared? Let's try these out here to make sure you guys are okay with the concept. And I'm going to say to you guys, let's kind of notice something here. Can I erase this? Here, you guys have that in your notes? Let me say a little something here about this. If you guys notice that, here's a fact. If I have a base to a power, and I multiply it to a base to another power, let's see if we can notice anything here. Okay, when we go through these examples, let's see if we can deduce what that might be. Okay, so what do you guys think? What could you say about this? 6x times 3. You guys know? What do you say about that one? Anybody know? 6x times 3? Is that 18x? Well, did you switch the order and say 6 times 3 times x? And then you got what, 18x? Everybody agree with that one? Is she right about that? Okay, and then we have what here? Let's switch the order. 6 times 3 times x times x. What do you guys get here? 18x to what power? Second power? Is that true? And then what about this? Let's switch the order. What do you write down? Negative 4 times 5 times what? Times y cubed. And what do you get now? Negative 20y to the what? Is that 4th power? How do we know that's the 4th power? Because I have one y here, and how many y's do I have over here? 3. Is it repeat multiplication? So I got my 3 y's, and another y makes how many? 4, you're right. You guys with me on that? Okay. Well, what about this? Negative 2y times negative 3. If I switch my order, what does that look like? Is that negative 2 times negative 3 times y? And what's negative 2 times negative 3? Isn't that 6y? What do you do about this? Switch the order. 2 times negative 3 times y squared. What do you get now? Negative 6y squared. Good. And what about this? Let's switch the order again. 4 times 3 times y cubed times y squared. Let's see what's happening. What's 4 times 3? Is that 12? 12 times y to the, uh-oh, what power? Why is it 5?
Because it's y3 times y2, and all you have to do is add 3 and 2 together.
Yeah, okay. Did you guys get that? Is that true? What does she say? Let's notice. Let's put this down here. We'll put it right here. Y to the third power times y squared. Let's see if we agree with this. Y to the third means what? I have how many y's? Don't I have 3 y's multiplied together for y to the third? What about y squared? What do I have? 2 y's multiplied together. What's going on here? Times? Is that true? So, is that repeat multiplication of the same base? What's the answer? Okay, I'll ask you again. Is that repeat multiplication of the same variable? Yes. What's the variable? We call that the base. How many of these do you see? 5. Do you have to go through this detail to deduce this? Maybe in the beginning you do. I used to be that kind of student. I had to go through that detail to deduce this in the beginning because I was like, okay, what really is going on? But after a while you start to realize that, hey, wait a minute. Isn't it true that if I had the same base with different powers, what did I end up doing with the powers? You added the powers. Is that right? So the tattoo I wanted to give you, or we can say here, is 3 plus 2 is what? Is 5. Is that right? Here's your final answer. What I wanted to express to you today is at least we know that if I have a base, what do I do with these powers? Anybody know? What do you do with those powers? You add them. So I'll put this in red. N plus what? M. That's a tattoo you guys want to get. You're going to be using that tattoo for a very long time. Okay, you guys okay with this? Anybody have any questions so far? Is that easy or is that hard? Well, good. It's easy because what comes next, you guys think? Anybody know? What will come next? I'm not saying we're going to make it harder, but what I'm going to say to you is we're going to kick it up a notch, a dimension, if you will. So I'm going to kick it up. I'm going to say to you guys, what do you think this is? 2 times 3x minus 4. This is what you guys had in the past already. We call this what? What do we call this? Anybody know? How did we remove that parentheses? Because remember, we can't subtract or add these here, right? These terms are not like. So how did we remove that parentheses? Because they're going to probably say, use the word, by the way, simplify. What they mean by that is remove your what? Parentheses. What property are you guys looking at now? Distributive property. Good. And by the distributive property, we know I take my what? This is equal to 2 times that 3x minus 2 times this what? 4. So what is 2 times 3x? Isn't that 6x minus what is 2 times 4? 8. Ladies and gentlemen, you wrote the equivalent version without the parentheses. You have simplified this. Okay? So this is what you did in the past. Do you guys know what you're going to do now, today? What do you think they're going to do to you now? This is past information. Today, they're going to give you things like 2x times what? 3x minus 4. They're kicking it up a notch. And how you do this is exactly how you did this before. When you simplify, remove these parentheses, again, you're using the distributive property. But now you're using it with what? Here we go. Isn't that 2x now times what? 3x? Minus your 2x times what? Times 4? Okay? Now, some of you guys are going to start to do some of these computations in your head. That's okay if you get it right. But if you don't get it right, what should you go back and do? You guys notice what I did in every one of these cases? What did I do? I took my time, and everything in red here, what do you guys notice I did? I switched the what? The order in such a way that I can simplify that. So in red, I'll say, do you guys notice how we switched the order in each one of these? The answer is yes. So we switched the order in each one of these. And when we switched the order, we did it in a way that did what for us? That helped us. Is that true? So all I'm saying to you is, some of you guys are looking at me and go, oh, Mr. Judge, this is so easy. I could do this in my sleep. Okay, good. Good for you. But if you were like me, you had to do this a couple of times. I don't know how many times I had to do it. Until I got so comfortable. And I started to remind myself, hey, the order in which I multiply does not matter. I could switch my order. And that helps me to simplify. So if you're that kind of student that's going to have to do every detail in the beginning, is that okay? Sure. That's okay. But then what happens after a while? You get more comfortable, you get more confident, and then what do you guys know? You're going to start to say, I don't have to switch the order every time I do this. I know that this is really what? What is it? 6 what? X squared, good. Minus what? Do you guys feel confident? You guys see what I'm saying? Okay, pretty good. Anybody have any questions on these that we're talking about? You guys have any question on this example? Any questions so far? No? Is this stuff still easy? Probably. Is it too easy? I might have to I didn't bring the book, so I'm going to have to rely on my worksheet today. So let's do the worksheet stuff. Okay? Here's one situation. Is that too easy for you? No? All right, let me give you some more then. Let's really make it what? Pretty hard on you. How about this? If they give you minus 8x squared times 2x plus 3. Right? And by the way, this is still considered a multiplication problem. Do you guys know why? Because what's happening between this negative 8x squared here and that blank space? You everybody know if they put a blank space there, what do they really mean? What do they mean? Multiplication. Okay, so we're multiplying, believe it or not, polynomials here. All right, you guys ready? Or are you just so happy to think about trick-or-treating later on tonight? You guys going to go trick-or-treating? Where's the best place to go trick-or-treating? Because I got to know. I want to know. I'm going to put my what costume am I going to wear again this tonight? See if you're awake. Huh? Who wore that costume? Russell Crowe? What was the name of the king? Or was he a king? No, he wasn't even a king. Do you guys remember his name? He wasn't a king, he was a general. Huh? You guys want to look that up? Should I show you my pictures? I'll show you some pictures later. Here we go. You guys ready? What are you guys going to do here? Since you're just thinking of trick-or-treating, I guess. Here we go. We have what? Negative 8x squared times 2x. This is plus. I can't even go see Justin Bieber with my daughter. She won't let me. Will you let your mom go with you? She doesn't. You don't like Justin Bieber? You should. He's pretty good. Yeah, my daughter, she won't let me go. She just won't. I'm lucky if she goes to the movies with me. I'm lucky. Even then, we have to go out of town. It can't be where we live. Is that sad? Is that what these kids do? Jeez. It's like... That's pretty sad. Okay. Here we go. Let's see if you're awake. Let's kick this up a notch. Okay? Here, we're going to give you something like x plus 3 times x minus 4. I'm trying to remember Math 110. Did you do this in 110? I don't think so. Did you guys do it in Math 110? Do you guys remember? I don't think so. So I'm lucky. It's today I get to show you a technique that's called what? Anybody know what I'm thinking? What's it called? You guys heard this before? Where did you hear FOIL before? Huh? In 110 they showed you FOIL? FOIL. The beginning of the end. FOIL. What does FOIL stand for? You're going to take your first terms. What are the first terms? These are your first terms. And then you're going to multiply your first terms. You're going to multiply your O terms. What are the O terms? Outer terms. You're going to multiply the I terms by the inner terms. So you're going to multiply the what? Out the last terms. That's FOIL. You guys okay with that? So go do it now. Actually, back in the day, they used to do these. You guys remember? Because a lot of times people like these arrows. So, I mean, you had distributive property before. You can handle some of these. A lot of people like these kind of arrows if you want to think of them as arrows, right? But back in the day, oh, there goes the devil outside. Back in the day, they used to do these. These are my first terms. These are my outer terms. These are my inner terms. And then these are my last terms. And then they would say, hey, okay, go do it. You guys see what I'm saying? I used to hate that because I was like, which is the first? I always had to draw my lines this way. So here's what I'm going to show you guys. Here's what I'm going to say. I don't like these lines. I'm going to create boxes. Anybody ever see this before? If you haven't, you're going to learn to love them maybe. Hopefully. Okay. I'm going to say, you see this first parentheses and you have a what? X plus 3. These are your rows, by the way. I drew a box with 2 rows. Do you guys know why I put 2 rows? Because I have an x plus a 3. I got 2 terms. So here's my rows. Put your x and put your 3. And 3 is positive. We don't have to put the plus sign, but we know it's positive. Okay? So if I have 2 terms in this parentheses, that's my 2 rows. Are you okay with that? What do I have here? Another 2 terms. These are my columns. So I have 2 columns. I got what? X, and I have a what? Negative 4. Because I have 2 terms. So draw a box with 4 of these spaces to work with. Okay? 2 rows, 2 columns. And you guys know what I get to do now? Here's what I'm going to do. I'm going to multiply each row with each column. You say, what are you talking about? Well, I got x times x. Isn't that the first row with my first column? Don't I, this x times x, I get to multiply my rows with my columns. And then I have an x times a what? I put an x times a negative 4? Yes. What is x times x, by the way? It's x squared. What is x times the negative 4, by the way? We write it as negative 4x. We like putting the number before the letter. Like 2 apples, 3 apples. And then what is 3 times my x? because I get to multiply my rows with my columns now. 3 times x, I just got through saying we like writing the number first. Well, it's 3x. And then what's 3 times that negative 4? Anybody know? What is that? Is that negative 12? So what do you guys see here as your entries? Write down your entries. This is equal to x squared, okay, minus 4x plus what? 3x minus 12. Okay? You guys okay with this? And so now what you get to do is what you did yesterday. What did you guys do here? What did we do yesterday? Didn't we combine like terms? We had to simplify by combining like terms. Which terms were like in this expression? Which like? Is x squared like x? No. X is like what? X. It has to be exactly alike. So what you end up getting here again is what? We get x squared. What's negative 4x plus 3x? What's negative 4x plus 3x? Is that negative x? And then minus 12? Can we combine this further? So ladies and gentlemen, you are done with your FOIL process. Here's FOIL. And for those of you that want to kind of remember, I know some of you guys might have seen this in high school. But this is my f term, just so you guys remember. X times a negative 4, that's my outer term. These are my inner terms, and this is the product. These are my last terms. So this is the FOIL mechanism. How you doing? I'm good. Do you remember FOIL?
Yes.
Okay. Well, she should go home then, right? You know it already.
Okay.
My job's so easy today. It was easy yesterday because we get to talk about fruit. It's easy today because we get to do what? FOIL, multiplication. Oh my God, you guys. You should just turn out the lights and anybody bring the cookies? No? Celebrate Halloween? Tell scary stories or something? Should I tell you some scary stories? I got a lot of scary stories. But all my scary stories are real. They're not made up. Anybody ever hear real scary stories in their life? Those are the worst. I don't know, maybe we should just do that. Turn off the camera and let's get some stories out. Real good ones. Okay. What time do we get out of here anyway? 50? Okay. What do you guys have to do to remove these parentheses? You're going to use the what? The FOIL technique. Again, if I were you, bring out the boxes. These boxes are your best friends. These two terms, these are my what? These are my rows, and what are these? My columns. So I have two terms here. So I have an x row and a negative 2 row. You okay with that? I got two terms here. I got a what? An x column and a 5 column. That 5 is positive. I usually don't notate the positive. It's kind of like you check your checking account balance. They don't put a positive 5 there. They just have a 5. All right? And then now, what do you guys do? You multiply your rows and your columns what? Together. Is that right? You guys okay with that? So let's think about this. What's x times x? X squared. Good. What's x times 5? 5x. Good. What's negative 2 times x? Negative 2x. Negative 2 times positive 5. Negative 10. Anybody have any questions on the entries? There goes a banana. Anybody have any questions on the entries? No? What do you guys do next then? Write all the terms and combine the like ones. You got x squared plus 5x minus 2x minus 10. Which terms are like from yesterday's homework? 5x and the negative, are the x terms are like. You just simply do the arithmetic with the constants in front or the coefficients in front. You get x squared now plus 3x minus 10. Ladies and gentlemen, you're done. You're done with FOIL. Okay, you guys okay with this? Huh?
I said I've never known FOIL like this.
I know. You've known FOIL like what? This. Exactly. You see this? I hated that. That confused me. Because I was like, well, okay, I mean, you learned it. I think it takes much longer to learn FOIL this way than it does to learn it what? This way, personally. And I even show in Math 110 students how to do this with a distributive property with these boxes, actually, by the way. I'm teaching during the winter Math 110, so we're going to videotape the 110 lectures. And then in spring, I'm teaching Math 125, videotape the 125 lectures. And then I have all of algebra covered. And about 5 years ago, I did statistics. So that's already online, period. So anyway, we'll have it all covered. Algebra through what? Statistics. Can I get rid of this here? You guys have that here? Okay. So here's your FOIL, by the way. Let's give you some more examples of FOIL. What if they gave you, let's kick it up, 2x squared plus 3 times 4x minus 1. Notice what I just did. We kicked this up a little bit. Okay? Now, in order to move the parentheses, remove the parentheses, you're going to have to use some what? Some FOIL. And like I said, you may enjoy thinking of this as my rows and as my columns. And I'll show you probably later why this is a good idea. I have 2 rows now and 2 columns again. So my rows, 2x squared, 3, because I have 2 terms. My columns, 2 terms. 4x, negative 1. Okay, so you're going to multiply your rows with your what? Columns. All right, let's see. We got 2x squared and 4x. If we multiply these, we did this earlier. These kind of problems earlier. What's 2x squared times 4x? 8x to what power? You see, what power belongs to this x? So what's 2 plus 1? 3. Is everybody okay with that one? We're using this fact that I left up. Now, if you don't like b, fine. Let's not use b. We want to use x. Okay, use x. This is now what again? Not b, but what? X. 2 plus 1 is 3. You okay with that? Now, what's 2x squared times a negative 1? 2x squared times negative 1? Negative 2x squared. Good. What's 3 times 4x? Is that 12x? What's 3 times negative 1? Is that negative 3? What comes next in this process? Don't we just write down every term? So let's write down every term. You get what? 8x cubed minus 2x squared plus 12x minus what? 3. And you are done. Okay, do you guys notice, are these terms like? No, we couldn't combine any. What else do you guys notice about this? Let's see if you remember from yesterday. How did I write my answer? Descending what? Powers. 3, 2, 1. What's the degree of this polynomial? What is it? Huh? What was the degree of this polynomial? Why do you say 3? Isn't that the highest power? Okay, good. Okay, so should I show you guys why you like some boxes? Anybody have any questions on this here? Is this still too easy? Is it easy? Should we kick it up a notch? Should I show you why maybe the boxes are pretty nice? All right, just to let you guys know why you might like the boxes here. They may give you 2x plus 5 x squared minus 3x plus 4. Now the problem with the acronym of FOIL is simply that, what? What do you guys think? What's the problem with FOIL? Huh? It only applies with a 2 by 2 situation like you see here. Okay, it only applies with that 2 by 2 situation. You don't have now 2 rows, 2 columns. What do you have? 2 rows and what? Exactly. So you're going to use a version of FOIL. I'm going to say this is one of the benefits to why I like the rows and the what? Columns. Okay? So if I look at it this way now, I'm going to have to draw this. How? How do you guys think? How many rows do I have to have? 2, because I have 2 terms. So you're going to have 2x here and 5. What about my columns? How many columns do I have? 3. I got x squared minus 3x and my 4. I'm still multiplying what? My rows with each column. I got 2 rows and I got 3 columns. So this problem becomes a little more difficult because you got 1, 2, 3, 4, 5. You got 6 multiplication problems to do. Okay, so with the 6 multiplication problems, let's see what happens now. What's 2x times x squared? Is that 2x cubed? You okay with that? What's 2x times a negative 3x? Negative 6x what? What's the power here? 1. What's the power here? Is that 1 as well? Oh shoot, I left it up. Power 1, power 1. This is power what? 2. Good, because 1 plus 1. Same base. Powers are the same, but we still just add the powers, so that's 2. 2x times 4 is what? 8x. Good. 5 times x squared, what's that? 5x squared. 5 times a negative 3x, what's this? Negative 15x. 5 times 4 is what? It's 20. So what do we do with all of this? Huh? What do you guys think? What do we do with this? Combine like terms? Does anybody see anything interesting about this scenario? Did you guys notice anything about any of these terms? Which ones are like? Did you guys notice that these terms are what? Are like. And do you guys notice what else? That these terms are like? Did you ever notice that? So, how about if we do this? I'm going to write this in descending order again. 2x cubed. What's 5x squared and a negative 6x squared when I add them or subtract them? What is it? Negative x squared. Is that right? If I have 5 apples, but I owe 6 apples, don't I end up owing an apple? Battery goes out on Halloween. Here we go. So what I was saying here, when you do your boxes, you could go back and do what? Combine like terms. The way we just did here. Okay, anybody have any questions on this one? You sure? Bless you. Should we do some easy ones or hard ones? Huh? do some easy or harder. How about this? See if you're awake. What if they gave you, we'll start with an easy one. X plus 4 what? Squared. Anybody know what that means? Huh? X plus 4 squared. You guys know what that means? Does that look like anything you might have seen before in your life? Does that look like anything? What do you think that, does that remind you of anything? I'm going to make the claim that this is a what? Exponential. I'm going to say this is an exponential. And what I'm going to write down here is kind of like a picture, again, of an exponential with the second power. Meaning, I'm not going to use a letter like B for base. I'm going to use a shape like a triangle, okay? Triangle to the second power is what? The base now is your triangle. Is that true? So if I have triangle to the second power, my base is a triangle. We need triangle now times what? Triangle. Okay, you guys okay with this? What if you had triangle to the third power? How do I write this exponential now? Triangle times what? Triangle times what else? Times triangle. I got 3 of them. Is that true? You guys okay with that? Now, I'm going to say to you that this is an exponential because what's in my triangle here? Anybody know? The x plus 4. So I can write this as x plus 4 times what? X plus 4. Okay? You okay with this? Now that you see this is an x plus 4 times x plus 4, what process do you use again here? What is this called? FOIL. Okay? So you got to use FOIL here. Now we have what? You got a row. This is your columns. How many rows and columns do you guys have now? What do you think? How many rows and columns do you have? 2. What are they? Let's write it down here. All right, we're going to write this down. Here's what I'm saying. You got an x and you got a 4. You got an x, you got a 4. Is that true? Do you necessarily have to draw your lines with your rows and your columns? Not really. If you start to get practice with this, you can say, this entry is my first row and my first column. That's x times x. What is x times x? Is that x squared? How do you get the second entry? Second entry is my first row, second column. What's x times 4? Is that 4x? This entry is my second row, first column. What's 4 times x? Is that 4x? And how do you get this last entry? Isn't that 4 times 4? Isn't that the second row, second column? So that's 16. If you don't want to do that, you can still just draw your what? Draw your lines. So it tells you what to multiply to get those answers. Where are you going? Oh. Oh. Oh, I don't think you want to take a picture today. Okay. All right. You just have to bring your costume back tomorrow.
Yeah.
Okay. All right, here we go. Do you guys notice anything here? Anybody notice? Aren't those terms like? So what do you end up getting? Isn't this x squared plus, what's 4 apples plus 4 apples? Your 8 apples, and then plus what? 16. Okay, now for those who are really awake, what if they gave you x plus 4 to what power? That third power. What if they made this really, really interesting? How would you do this? Okay, I'm just going through some of these examples here. What if they gave you that? Anybody know? What do? Isn't that true that this is x plus 4 to the what? Well, what is this anyway? Is that an exponential? Yes. What's the base? Anybody see the base here? What's the base for this exponential? Isn't that x plus 4? So how many copies of these x plus 4 do I have? Anyone want to tell me? I got 3. How do you know there's 3 copies of those? Because of the power, okay? So what are you supposed to do again with your bases? Aren't you supposed to what? Multiply? You okay with this? Here we go. I'm going to make the claim, the following. Do you already have, by the way, x plus 4 times x plus 4? Or I should say x plus 4 times x plus 4. Doesn't even matter. Do you already have an x plus 4 times an x plus 4? What do you think? Okay, let's use these here. What is x plus 4 times x plus 4? It's right here, isn't it? Isn't it x squared plus 8x plus 16? So I can replace this with what? X squared plus 8x plus 16. This is my product right here. So I already have that. And then I have to multiply this with what? Another x plus 4, because this is repeat multiplication. So what you're going to do again is you can go about this in terms of your boxes. We can say, these are my rows, and these are my what? Columns. So if we multiply our rows and columns, how many rows do I have now? I got 3 rows. Is that true? So let me draw my 3 rows. 1, 2, 3 rows. Then I have my what? 2 columns. X squared, 8x, 16. I got 3 terms. I got 2 terms for my columns. Do you guys see what I'm saying? This could make this a lot easier. It's a lot more visual. If you want to draw your lines again, maybe you like that. That's fine. We're almost there. Let's see. Let's finish this off. What's x squared times x? Isn't that x cubed? X squared times 4. 4x squared. 8x times x. 8x squared. 8x times 4. 32x. 16 times x. 16x. 16 times 4, what's that? Is that 64? Anybody notice anything interesting about the terms being like? Aren't these terms what? Like. Aren't these terms what? Like. We're almost there. Let's take a look. What are the final answers here? So let you guys know. What are we going to say? X cubed, go on. What else? 8x squared plus 4x squared? Is that plus 12x squared? 16x and 32x, what's that? Is that 48x? Plus, what number's left? 64. Ladies and gentlemen, you're going to work on which worksheet tonight? The multiplication of what? Polynomial worksheet, okay? That's your homework tonight. Work on that worksheet. We're going to continue with more tomorrow. Okay? Well, all right, thank you. Okay, let's take a look at this. We're going to continue our multiplication with polynomial concepts here. Okay, so we're going to still do this multiplication with polynomials, and you guys already know we learned 2 techniques, distributive property and FOIL-like, I guess. So what are you guys going to use here? Distributive property? Okay. So you're going to multiply the three terms by this first term outside. This is multiplication. So you guys know what that means is I'm going to take 2/3 x to the 4th times that 6x to the 5th minus 2/3 x to the 4th times that 12x cubed minus the 2/3 x to the 4th times the 1/3 x. Okay? So this first term here gets multiplied to each one of the terms. And as we talked about yesterday, what should you do? What do you guys think with these? What's the move now from yesterday? Aren't we going to have to do what? Maybe rearrange the what? The order in a way that we can multiply and simplify, meaning take the 2/3, multiply it with 6, and you have x to the 4th, x to the 5th left. Is that true? Didn't we just rearrange the terms? We get the numbers on the left and the letters on the right. Okay, let's do that. Let's rearrange our terms. Minus 2/3 times 12 times x to the 4th with x cubed minus 2/3 times 1/3 x to the 4th times x. So let's see, let's try this out. And then let's notice a couple of things. Here's what we have to remember. What is 2/3 times 6 anyway? How do you multiply a fraction with a whole number? Yeah, or we can say, what is the 6 multiplied to? The 2 or the 3? It's the top, right? So don't you get 12/3 here, really? Because 6 times 2? Yep. And then don't forget, this is x to the 4 what? Plus 5 power. We add the powers. And then here, this is minus 2 times 12. Isn't that 24/3? Then you get x to the 4 what? Plus 3. And then this is minus 2. We're multiplying fractions again. So I'm going to have to remember how to do arithmetic with fractions. So how do I multiply 2/3 times 1/3? Is that 2? Yeah, you multiply across, right? So you get 2 over what? Over 9. X to the 4 what? Plus 1. Why is it plus 1? That x has a 1 power. Good. So these are kind of things we looked at yesterday. Now let's finish this off. Let's give the answer. What's 12/3 again? 4. X to the, what's 4 plus 5? 9. Minus 24 divided by 3. 8. X to the, what's 4 plus 3? 7. Minus, can I simplify my fraction 2/9? So it'll be minus 2/9 x to the, what's 4 plus 1? 5th power. And you are what? You're done. All right, you guys okay with that first one? Did you guys get that? How many people missed this one? Okay, if you missed it, do you know where your error is? Where's your error?
And of the arrangement of things, I didn't do that right. That's what made it look very confusing.
Got to be careful. Got to be patient. You know what I'm saying? Focus on the arrangement. Okay. All right, let's look at the second one. The second one we're working with today is continuation of this sort of multiplication of polynomials. X minus 2/5, right? Times, is that x plus 1/3? Okay. All right. Okay, so yesterday I showed you guys a technique called what? FOIL. Is that right? So we learned about FOIL yesterday, and I drew a picture for you of FOIL, really. If we think of this as our rows and this as our columns, we have actually a nice picture of FOIL that I find very useful. Some people find very useful. Of course, if you don't want to do this, that's okay. Do your line technique, and as long as you get your answer right. So remember, I have two terms. I have an x term, and I have a what? Negative 2/5. These are my rows. I have an x term, and I have a what? 1/3. These are my columns. So yesterday, what did you guys do with this? you multiplied your rows with your columns, right? Is that true? Right. Anybody here yesterday?
Yes.
All right. Okay, here we go. What's x times x then? Is that x squared? Okay. What's x times 1/3? 1/3 x. What's negative 2/5 times x? Negative 2/5 x. What's negative 2/5 times 1/3? Is that negative 2 over what? 15? Because you multiply the 2 with the 1, 5 with the 3. Okay, you guys okay with that? And then notice yet again, you're going to have some like terms here across these diagonals. And you're going to get now, let's take a look. X squared plus 1/3 x minus 2/5 x minus 2 over what? 15. My F term, my O term, my I term, my L term. Here's your FOIL again. Okay, so now you guys are going to notice we have like terms here in which we have to perform arithmetic with our what? With the constants, right? This is plus 1/3 and a minus what? 2/5. We're going to have to combine our like terms. So this is adding and subtracting here, polynomials. These are the only terms we can add. So what that means is I have some work to do. And the work I have to do consists of taking the coefficient 1/3 and subtracting what? 2/5. So I'm going to have to remember how to subtract fractions with different denominators. Okay? Don't look at your fraction work as just, oh, that's too much to do. Look at your fraction work as an investment in yourself. Okay? You are worth investing in. Is that true? So invest your time in doing your arithmetic with fractions because that's not going to go away. Okay. How do we do this when they're unlike? Well, what's the LCM of 3 and 5?
15.
So put that where? Here and here. Is that right? So I get 1/3. I get 2/5. And you guys remember, how do I do this? 3 times what is 15? 5. 5 times what is 15? 3. So don't we get what? 5, 6. Okay, what's this going to give you? Right? Our denominator is 15. These are like fractions. 5 minus 6. What's that? Is that negative 1? So our side work gives us the coefficient that we need so that our final answer becomes x squared minus 1 over 15x minus 2 over what? 15. And you are what? Done. Okay, so notice what we're doing today. Some of these problems we're working on today were the topics we talked about yesterday, but now there's a little bit of more interestingness to it. I guess fractions, and you'll see some other things. Okay, you guys okay with that? All right, anybody have any questions on this one? You sure?
So if you have a fraction, you just move the first upside down, right? No.
Nope. We didn't move anything upside down. Do we move anything upside down? What is upside down?
The 2/5 and 1/3. Right there's 1/3 and the other one's 2/5. So you just move it the other way around?
Well, we added 1/3 with, or we actually subtracted, right? We took 1/3 minus 2/5. We have to get 1/3 minus 2/5. So once we deduce that value being negative 1/15, you put the negative sign at the same level, I guess. Okay, so let's look at number 3. Yeah.
I put negative 2/5 plus 1/3.
Okay. If you put negative 2/5 plus 1/3, you should still get, when you do the arithmetic, you should still get the same answer, negative 1/5. Okay. Yeah. Yeah, it'll be okay if you did that. Oh, I see what you're saying. Yeah, how I wrote. Oh, I wrote it this way. FOIL. Yeah, I see what you did. You wrote it this way. That's okay too. Yeah, if you're going to do things consistently, though, I mean, if you, let's say it this way. If you're consistent, then you're going to get the same answer. And it won't be a problem. Okay, so number 3, 1/4 x plus 2. Oh, look at that. 1/4 x plus 2, and then the next one will be 3/4 x minus 1. Okay, so you're going to create your boxes. This is FOIL again. Okay, like I said, here are my rows. Here are my columns. Okay, so I get a 1/4 x, I get a 2, I get my 3/4 x, I get my negative 1. Okay, multiply your rows with your columns. Now, be careful here, right? What's 1/4 x times 3/4 x? What is it? 3 over what? 3 over 16. And then, what's the x times x? Good. 1/4 x times negative 1? Negative 1/4 what? X. 2 times 3/4. Is that, that's going to be 6/4 x. Is that true? We'll just write it down because you make it, because this 2, remember we can think of as 2 over what? 1. Doesn't matter. 2 is really multiplied just to the numerator. 2 times 3 is 6. And then 2 times negative 1 is? Okay. So, anybody notice again? Do we have some like what? Like terms? Okay, so we got 3/16 x squared. What's 6/4 minus 1/4? Because remember, if we write down 6/4 x minus 1/4 x minus 2, I'm going to have to combine now what? My 6/4, well, these are like terms. So what's my arithmetic going to be? Good. It's what? 5/4. Is that true? So some of you guys can look up here and do it and say, well, if I could notice that they have the same denominator, they're like, can I just say 6 minus 1? You can, and what do you get? 5, so that's 5/4. Don't forget your x term minus your 2. And you are done. Okay, so this is kind of some of the practice we've been doing here. Anybody have any questions on this one? Okay, let's take a look. Let's look at number 4. So, oh, look how beautiful. I like this one, number 4. Look at that one. Isn't that nice? Oh, let's look at this. I can't wait to do this one. X squared minus 3x plus 2? Is this the one that people get scared about and say, oh, forget it, I'm going home? Right, what's the x squared plus x plus 1? Look at this. Now, we can't call it FOIL anymore. Because FOIL is specific. It's product of the first terms, product of the outer terms, product of the inner terms, product of the last terms. So the reason I stick with the boxes is because you can use this box technique in general. And when we have like no acronym for it, you know. So I just have to think of, well, these are my what? Rows. And what are these? Columns. So that I have 3 rows and I have what? 3 columns. So if we notice, we get what? X squared and what? Negative 3x, and we get 2. We get x squared, and you get what? X, and you get 1. We're going to take our rows and multiply it with our what? Columns here. So just have some fun with it. All right, let's see. Okay, what do you guys know? What's x squared times x squared? Say x to the fourth. X squared times x. X squared times 1. Minus 3x times x squared. Is it minus 3x to the third power? Why is that the third power? We're adding the 1 with the 2, right? So we got 3. I got 1x and I got 2 more, makes it 3. Then what's minus 3x times x? Is that minus 3x squared? And minus 3x times 1. Then I got a 2 times x squared. What do you get there? I got a 2 times an x. What's that? And I got a 2 times 1. What's this? So notice I got like 9 problems really to do for the price of 1. One good one. Okay, so let's see how we handle this, right? Does anybody notice when you look back at all of these terms? Do you guys notice anything about the like terms? They're diagonal, is that right? That's a good observation, meaning, oh, look at that. These are the x cubes. What are these? X squareds. And what are these? Yeah, the diagonal terms are pretty what? Look at that. So let's write this down. What you have now is going to be, let's erase this. We have x to the fourth now. Let's see. That's minus 3x cubed plus an x cubed. These are like, this is the addition of polynomial work. So if I owe 3 apples and I have an apple, what's my story with my apples? I owe 2 apples. So I'm going to put minus 2 what? X cubed. You okay with that? Now let's look at our banana situation. These are like 2x squared minus 3x squared plus an x squared. 2 bananas. And I owe 3 bananas. What do you guys think? Do I have a banana or am I owing a banana? I owe a banana and then I have one. What's going on with my bananas? They're gone. Right? Or you can think, I got 2 bananas and I got a banana makes 3 bananas and I owe 3 bananas. My bananas are gone. I have no more bananas. Is that right? Now, what are these going to be? Apples, bananas, what comes next? Pears, good. I got 2 pears and I owe 3 pears. What's the deal with my pears? Do I have them or do I owe them? How many pears do I owe? Oh man, look at that. And then I just have plus $2. So what I'm saying to you is you can go through this if it's nice arithmetic. If it's fractions, you're probably going to have to write it all down because there'll probably be some work to do. But anyway, this is a good one. Don't you guys like that one? It's not, see, I mean, if you took your time and you were patient, you didn't, what? That didn't hurt too bad, right? Okay, you guys okay with that? Anybody have any questions on this one? Sure? It's better than Halloween trick-or-treating? Anybody go trick-or-treating here? You did? You went trick-or-treating, you guys? Really? What was your costume? Why come you didn't wear it yesterday? What did I do? I was just scared all the kids giving candy away. That's all I did, gave out candy. Came to the door, had to give candy to. You know what I noticed about people's costumes this year? What do you guys notice people dressing as?
Nerds.
Where? Really?
There's so many nerds.
I didn't know that. Zombies?
Anime cosplay?
Anime?
Yeah, anime cosplay, yeah.
I didn't. Where did you guys go? Where'd you see the nerds? Really? That wouldn't.
Parties I went to on the weekend, there was like, all it was like nerds.
Really? It wouldn't be too hard for me to be a nerd. So,
All you have to do is wear those glasses with the
Exactly. I just have to find some broken glasses, and it wouldn't be hard for me to be a nerd. So, yeah, I've seen a lot of people with fake blood and clown. I don't know, like serial killers or something.
Well, my friend was a clown.
All right, well, back to reality. Here we go. It's easy to, you guys see how easy it is for me to lose you? I could do it like that. I can walk out the door, you wouldn't even notice. X, 4, x minus 4. Let's take a look. You get what? X squared, and what else you get? Minus 4x. What do you get here? Plus 4x. What's 4 times negative 4? Negative 16. Oh, ladies. We're doing some investing. We're investing. Anybody notice something here? Take a look at this investment. You're going to love this investment. Look at this. What happens to your O&I terms? They're gone. Is that true? Oh, that's so nice. So, okay, we're going to put down what? X squared minus 16. There you go. Wow, look at these problems. Good, okay. All right, let's look at number 6. Let's look at number 6. Hopefully you guys notice some interesting things about this. Number 6, what do you guys have? 2x plus 1/2, 2x minus 1/2. So let's see what happens here. 2x plus 1/2, 2x minus 1/2. So we're going to use FOIL again. Right? Put our boxes now. Remember, the first 2 terms are the rows. The last 2 terms are the columns. Just to emphasize that again. Rows, columns, and then you got FOIL up here. I'm going to call that my FOIL method. Same thing here. We use FOIL. Okay, first terms, outer terms, inner terms last. So let's write down. I have the 2x row and the 1/2 row. I got the 2x column, and I got the what? Minus 1/2. So let's see. What's 2x times 2x? 4x what? Squared. Why? X times x is x squared. 2 times 2 is 4. What about 2x times a negative 1/2? Do you guys know what 2x times negative 1/2 is? I might have to write that down. Let's see. 2x times negative 1/2. If I switch the order, aren't I multiplying 2 with a negative 1/2? What's 2 times negative 1/2? Ah, I love it. Woo, look at this. 2 times negative 1/2 is what? 2 times a negative 1/2. What am I going to multiply this 2 with? Is that a fraction? Okay. 2 times what number? Not 2. I know what you guys, that's what I'm saying. 2 is not multiplied. You can't multiply this 2 with any number you want, ladies and gentlemen. You can't say, I like the 2, I'm going to multiply it. No. 2 is being multiplied to the top number. If you want to deduce the answer, we can say positive times a negative simply is negative. Is that right? And then that 2 has to be multiplied to the 1, so that's 2. 2 times 1 is 2. Don't forget you're dividing by what? 2. So what's 2 over 2? That's negative 1. So what I'm saying is that 2x times negative 1/2 is simply negative x. That number is a negative 1. You okay with this? Be careful. Ooh, yeah. Invest in some fractions. How about this? 1/2 times 2x. What do you think that is? I don't know. Let's see. 1/2 times 2x. Is that 1 multiplied to what? Is that 2 multiplied to what? Aren't they multiplied to each other? What's 1 times 2? Divided by 2? So it's 1x. And then what's 1/2 times negative 1/2? Negative. Positive times negative is negative. 1 times what number? 1 is 1. 2 times what number? 2 is 4. It's negative 1/4. So multiplying fractions, ladies and gentlemen, you have no choice. You multiply the numerators, top numbers together. You divide by the denominators, the bottom numbers together. You keep your division. So you multiply, what I mean across horizontal. Not diagonal across, horizontal. Okay, you guys okay with that? Those are things you're going to invest in. And if you have an apple and you own an apple, your apples are what? Gone. Final answer is you have 4x squared minus my what? 1/4. Does anybody notice anything that's going on here? The last, I would say 5, 6. You guys notice anything yet? Huh?
In multiplication,
Mm-hmm.
you were adding like the same, you have the same amount, the same numbers but different signs.
Really?
So you can't, so one of them ends up canceling out.
Well, let's see. I have, let's see number 7. What is number 7? 5x and a 1. Is that right? What else do I have? 5x and a 1. What do you guys see that's going on here? One you're adding and one you're what? Subtracting. Do you guys know this is a special situation? Okay, this is special. I want to say your first terms are the same. Your last terms are the same. When your first terms are the same and your last terms are the same and the signs are opposites, you guys know what's going to happen? First terms are the same. Last terms are the same. Signs are opposites. First term's the same. Last term's the same. Signs are opposites. What will always happen is your O and I term will what? Cancel. They're gone. Always, always what? Always. What does always mean? That means, in this case, my O and I term are going to what? Cancel. You can bet the farm. Let's double check. Let's see. If I draw my FOIL boxes, I want to double check if my O and I terms go away. Let's say I got 5x, I got 1. These are the rows. I got 5x and I got negative 1 for my columns. We're talking about the FOIL process. So let's do this. What's 5x and 5x? 25x squared. What's 5x and negative 1? What's 5x and 1? What's 1 and negative 1? Are my O and I terms going away? So what's the final answer? 25x squared minus what? 1. Should I prove that to you guys? Let me show you. I'm going to do this in general. Triangle plus square. Triangle what? Minus square. Okay, so I'm going to emphasize that this is going to be plus. This will be what? Minus. So notice, right? So notice this fact here. You got the same first terms called a triangle, same last terms called a square. So if I do this, if I bring out my FOIL box, I can prove to you this concept in general, is that triangle times triangle is triangle what? Squared. Triangle times minus square. Minus triangle square. Square times triangle. Or triangle times square. Triangle square. Square times that minus square is minus square to the second power. So notice again, in general, I didn't put any numbers, I didn't put any letters or numbers and letters. Your first term, your last term, your O term, your I term, the O and I term goes away. So you're left with triangle to the second power minus square to the second power. And we call this really here, this answer is known as the difference of what we call perfect squares. You don't have to know this today or in this chapter yet, but you will in the next chapter. But this is a special situation, okay? So what you're looking at is a special situation where the O and I terms go away. That's what we're looking at. So if we look at number 8, what should we expect for 8? We got, look at number 8 now. X squared plus 1, x squared minus 1. What should I expect when I use FOIL here? Anybody know? Yeah, the O and I terms are going to go away. How do you guys know? The same first terms, the same last terms, and the signs are plus and minus, or minus and plus, by the way. Doesn't matter. X squared 1. X squared what? Minus 1. So what's x squared times x squared? What is it? Is that x to the 4th power? What's x squared times negative 1? Negative x squared. 1 times x squared. 1 times negative 1. Anybody notice what happened here with my x squared terms? Aren't they gone? What do you have left? X to the 4th minus 1. Let's look at number 9. I'm going to do something here with number 9. I'll put x plus 1/2 here for number 9. I'm going to put another x plus 1/2 here. Okay, so I'm going to change that one on you. And the reason I'm going to change that on you is, why do you think? Do you know what the most common error to this problem is? What do you think? It's not the fractions. What's the most common mistake? They think that, people can think that the fact is applied here. And I'm going to tell you, no, you can't apply this fact. You say, well, why not? Because you got plus and you got what? Plus. Those are the same operation. The fact applies only to when you have opposite signs, not the same sign. Meaning your O and I terms are not going to go away now. And let me show you. Okay, because some of these are problems these are all problems selected from your textbook for homework. So we got x with 1/2, and you got x with 1/2. So let's use our FOIL. We got x times x, which gives us what? X squared. What's x times 1/2? 1/2 x. We always put the number before the letter. 1/2 x again is what? And what's 1/2 times 1/2? 1/4. Good. 1 times 1 is 1. 2 times 2 is 4. So when you write this down, notice again, what do you guys have here? Like terms across that diagonal. Is that right? So if I have half an apple, and I got another half an apple. Right? What do you guys think? If you have half an apple, and you have another half an apple.
There's 1 whole apple.
Good. 1 whole apple. So I'm going to put plus 1 whole apple. Don't forget your plus 1/4. You guys okay with that idea? Sometimes people don't think about this and go, 1/2 plus 1/2 is really what? 1. Half an apple plus another half of an apple makes a full what? Apple. Did your O and I terms go away? No. So you got your first term, outer term, inner term, and your what? Last term. We have a question?
You don't have to put like 1x, or you just put
You know, you don't have to. No, that's a good question. You don't have to put plus 1x. If you did, would I get mad at you and mark it wrong? No.
because I put 1x.
I know. But you want to know what you might see in back of the book as an answer? That 1 will be gone. Yeah, I mean, that's a good point that you make. You know, it's kind of like when I say to you, what does this mean? How many? 1 apple. What does this mean? 2 what? So I can understand you want the desire to put what? A 1 here, but it's just not necessary. Are you okay with that? Okay. And then what do you guys notice with these other 2 problems? What do we see? What's number 10? X plus 1 times what? X squared minus x plus 1. So you got how many rows here? You got 2 rows. How many columns? 3 columns? X, 1, x squared minus x, and 1. Okay, so you're going to fill your entries. You can multiply every row with every column. So what do you have when you do that? X times x squared gives you what? X cubed. What's x times minus x? X times 1. 1 times x squared. 1 times negative x. 1 times 1. So what happens along the diagonals? You guys see some like terms? Yeah, you do. And then notice what happens now. Yeah, we got x cubed now, and I got my apple. I got an apple. I owe an apple. Apples are gone. I owe a banana, and I have a banana. Bananas are gone. This will be plus what? 1. So you got an x cubed plus 1. What do we have next over there? Okay, let's look at number 11. What's number 11 say? You got what? Is that x plus 2 or x minus 2? Oh, x plus 2? You want to change it to x minus 2? No? How come? Let's try this one instead. Here we go. I got 2 rows and I have what? 3 columns. So now I have an x times an x squared. What do you get? x times 2x, what's that? X times 4, 4x. Negative 2 times x squared. Negative 2 times 2x. Negative 2 times 4. Okay. Did you guys notice anything canceling? I don't know. You guys notice these are like terms?
You wrote x plus 2, not x minus 2.
I know. We just changed it. So we get x cubed. Notice this. What happens with my apples? They're gone. What happens with my bananas? They're gone. You got what? What I wanted to show you guys is that there's a couple of situations in which these are not FOIL. Because FOIL applies to only first, outer, inner, last. But there's some analogous situations that are happening where? Here. Now, it may not be such a big deal to you right now, but come the next chapter, what's the story? It's going to be a lot bigger a deal for you. So you should have seen, hopefully, some of these special cases. And when we get to the next chapter, I'm going to remind you and say, hey, remember what happened here? We got some time. Does this always happen? What do you guys think? There's another 12, number 12 here. It's right here. It's 2x plus what? Plus 3 times x squared minus x plus 4. Here it is. Am I going to get cancellation, you think? So far we had some examples where it happened. Does it always happen? No, let's see. To x3 x squared minus x 4. Let's see, what's 2x times x squared? 2x cubed. What's 2x times negative x? 2x times 4? 8x. 3 times x squared? 3 times negative x? 3 times 4? 12. Let's see. Do we have like terms across the diagonals? What do you get? 2x cubed. What's 2x squared minus 2x squared? Is that plus x squared? 3 apples minus 2 apples is 1 apple. Negative 3x plus 8x is what? Plus 5x. And don't forget to add your 12. What I want to show you is that this kind of process just doesn't what? Where things fall out, doesn't always happen. It only happens in very special situations. Question?
Will you mark it wrong if you mess up on the signs?
Yeah. Yeah. I'll mark it wrong if you put your signs if you mess up on your signs. You know why? Would you get mad at the bank if they mess up on the signs for your balance?
Yeah.
You would?
Well, it
Depends on the sign. If it's a negative and they put positive, you're probably going to be okay. But you guys want to know something about banks, what I always discovered? They usually make mistakes in what direction? Not in your benefit, what? In their benefit. So if you notice your balance is really positive, they mess up on the sign and put negative, are you going to go yelling and screaming at the bank? Of course. So why do I say to students that if you mess up on the signs, you get it wrong? You might go work at the bank. And then my balance will be affected. Do you guys see what I'm saying? That's really the reason. You might be a banker. Anyway. You got your homework. You got your what? You guys are free to now invest in yourself. See you guys later.